Welcome everybody to the Dwell Time episode number 2. On this session, we're going to be talking about high density Wi-Fi in stadiums, arenas, and auditoriums. Kick things off, we've got the usuals on here. Myself, Jerry Olla. We've got UC. You want to introduce yourself, UC?
Hey guys, Jussi, janitor coming up. How are you? Nice to see you, and thanks everybody for joining.
And you see, you're going to help kind of drive things on the visual side to help articulate some of the stuff that we're going to be talking through. Joel, how about you? Are you going to be on as well, helping us?
I'll definitely be in the background, maybe answering some questions via the chat and maybe the Q&A tool. Because I'm currently in a closet right now because we're in the middle of moving and there's no furniture in the house or anything like that. So greetings from inside the closet. But yeah, if anybody has questions, anything like that, definitely chat it up using the chat tool, and feel free to put your questions in the Q&A tool. Really good idea to put your questions in the Q&A tool itself, because that way they'll be like, there's like a queue in there and we'll be sure to get to those. But then, yeah, just general stuff, feel free to blow up the chat. So,
yep.
Yeah,
if we tell you to put it into Q&A from chat to Q&A, it's not because we're bothered by it. We want to make sure that we don't miss that question. So yeah, definitely use the Q&A so we can track those and make sure we get those answered. All right. Other than the usuals, we've got a few special guests on this episode to help us with this very kind of heavy topic of high density Wi-Fi. We've got some heavy hitters. Ben, you're on the line. What you want to introduce yourself?
So, hi everyone. I'm Ben Toner. I work for myself under numerous networks, and I also work as a consultant for Real Wireless, who are the UK's, and if you read their website, the world's most trusted advisors to stadiums. So a lot of work with UK stadiums, helping them get their Wi-Fi and general cellular installed.
Awesome. Thanks for joining. Chris, you're on the line. How about you?
Chris Reed. I'm a principal consultant with Verizon, doing a lot of our large venue Wi-Fi work, and have been doing large venue Wi-Fi since about 2012.
Awesome. And Dan, how about yourself? Oh, got the mute.
There we go. Temporarily unmuted. Nice. Got there eventually. How many years are we doing this now? 3 years? Something like that. Still can't figure it out. Brilliant. Yeah, no, I'm Dan Jones. I'm a wireless engineer at a company called Natilic in the UK.
Awesome. Yeah, I really appreciate you guys joining this topic, because definitely going to be leaning on you guys quite a bit for your expertise on this high density Wi-Fi. To kind of set the stage here, what we're talking about when we talk about high density Wi-Fi, we're talking about essentially just a large number of Wi-Fi devices in a relatively small area. So this session, we're kind of specifically focusing on things like these large public venue type environments of stadiums, arenas, auditoriums, those kinds of things. But yeah, really high density Wi-Fi is any of these areas that you have a lot of users, a lot of Wi-Fi devices in a relatively small area. So yeah, let's talk about some of the challenges then that presents. So when we talk about these high density of users in these small areas, generally we're also talking about things like multi-level spaces. What kind of challenges do you guys see when you're dealing with multi-level spaces when it comes to Wi-Fi design? And for the audience, I think it's good to kind of differentiate between kind of your standard Wi-Fi design and this high density Wi-Fi design. So when we talk about high density and multi-level spaces, what are some of those kind of considerations that you guys have to throw in there? Maybe Dan, you want to take that one?
Yeah, sure thing. Multi-level space. I think one of the main things is the kind of bleeds that you get from one space to another space, right? So trying to like almost contain where you're going to put wireless and how you're going to put where you're going to mount things, how you're going to mount them, what types of APs, antennas you're going to use, things like that. And that's one of the main things, is like making sure that, yeah, especially if you've got a space that changes use. So if you've got like a stadium where, you know, they have sports things and every seat's full, and then that changes to they have a concert and, you know, the bit behind the stage isn't full anymore, you know, all that kind of stuff. So I think just being aware that that initial use might not be the only use as well of a space can be quite a challenge to think about.
I've never played 3D chess, but I feel like, yeah, when you're dealing with high density Wi-Fi and multi-level spaces, like designing Wi-Fi is, you know, kind of like playing chess, and you got to have all these strategies and stuff. But then, yeah, you take these like high density Wi-Fi and multi-level spaces, and now all of a sudden you have the 3D kind of element to this of, yeah, where are the users, where can you put the APs and all this kind of stuff. It really amplifies the complexity and the strategy behind the design.
Yeah, and so for those multi-level spaces, I think that those considerations are important, but one of the things that you're trying to drive towards is managing where those clients are roaming. If you were to throw, if you've got a let's talk an arena, there's a press level up at the top, there's concourse areas, the suites areas. If you just throw omnis out everywhere, clients can see all of those. And there's not going to be a single AP or radio that has dominance in that space. So you might have a client that's on the floor that's connecting up to the press level. You're trying to manage the RF to make sure that the clients are making good decisions, that they're not connecting to APs and radios that you don't want them to, so you can keep that data rate high and minimize the airtime that they're going to be using.
Very good. What about some of the bandwidth demands? What are you guys seeing in these kind of high density Wi-Fi environments?
This is one of those ones that when you start the project, the requirements are always high. They're always high. And actually, when you look on average at what those bandwidths typically are and what ends up getting designed for in like world-class soccer games and so on, it's about somewhere less than 0.5 megabit per second per user, maybe even a quarter at times, because it on average, right, just because of the way it peaks and flows. But yeah, we see now specs coming out anywhere from like 1 to 4 megabit per second per user as a nominal spec. And that's designed around being able to deliver sort of the typical use cases people want. So action replays in a seat or something like that, getting some video across. Yeah, but realistically, when you do the numbers, when you look at it statistically, you're looking at a fraction of a megabit per second over time.
Right on.
How does that then relate to, sorry, Jerry, can I drop in a question?
Please do.
Follow-up question for Ben. How does that then relate to like clients per radio on an AP? So if it's like quarter or 0.5 megabit or a megabit, what kind of clients per radio demands are you looking for, or what are you designing for in terms of that?
So I tend to come at it from both angles just to prove to the customer that it's about right. So sometimes if they kind of know what they want, you look at kind of a statistically, it's okay, like 50% of the people will be downloading some video and so on, and you get to this number and you get to this aggregate number. And typically having designed for Wi-Fi 5, you would be getting to the kind of 75 megabits per second per radio at an aggregate, and then where you typically would say, okay, so we're designing for 1 megabit per second per person, and so we're going to get put 75 people on here, something like that typically, and that adjusts and that goes around. There's often a fraction of but only 60% of those people will ever be using it at any one time. It's all a bit of a numbers game. It's all a bit of just looking at this statistically, but yeah, typically speaking, somewhere around the 70-75 people per radio in high density is what we've seen as the targets.
And that's designing to the seats for the most part, that we're not really in the seating sections. We're looking at the individual seats and trying to cover a specific number of seats to meet that requirement per radio.
Interesting.
And then
the specification. we'll always have the caveats of we're assuming one device per person or whatever that might be, right? In use.
Exactly. What about like 2.4 versus 5? How much do you kind of plan for 2.4 being utilized versus 5 gigahertz? What is the target? What usually ends up happening?
Quite frankly, I don't. If at all possible, 2.4 just does not exist in the bull spaces. The only time it might be used is for some specific back of house requirements, but never on the public side. I know we've got 60 megahertz of bandwidth to play with there. But managing clients, making sure that they're not connecting it to those radios, making sure that they're not crossband roaming and having kind of an okay experience or a good experience and then down to a poor experience. It is easier and I think a more reliable experience for them if they're staying on 5 gigahertz. And now we're starting to see them move to 6 gigahertz as well. But 2.4 for the most part for me it's a back of house only and only in specific areas that it's required.
Yeah, and one of the things that I've noticed a lot in the high density areas, it tends to be people put their phones in battery saver mode. So all of these nice kind of 2x2 clients that you have all of a sudden become one spatial stream, right? And that's like another consideration to have. So I think sometimes like I used to take it for granted that, most people have got like a new iPhone or a new Android or something like, and when I say new, I mean the last 10 years. So it's going to be 2 spatial streams, but actually and battery save mode. And I think another thing in terms of like the thought process of what these devices are going to be doing, right? Yes, they're going to be checking scores. Maybe they're going to be looking at other things that happen, other sports that are happening that aren't in that particular stadium or something like that. But also one of the main things, the main traffics that we see is actually just uploading photos or videos that they've taken. They take the video, they take the photo, stick it in their pocket, and now that device is just in the background the whole time, just uploading that stuff to the cloud. And so things can end up being a lot noisier on the upload than you're kind of necessarily expecting.
So when
I would add to Dan's comment there and just say, a lot of our models in terms of what sort of aggregate bandwidth we're going to get through, looks at specific use cases. And I think one of the things that has been often overlooked is just that. It's like just taking a photo, which you did not intend to perform an online service with, is actually an upload. There's a question on the Q&A about what is the upload bandwidth and those kind of things that will actually add to that. But luckily, it tends to be all really on the uplink, that kind of thing.
I've always wondered why there isn't a standard for postponing low priority things like image uploads, for example, to the cloud, like uploading backup images to the cloud and stuff like that. Because is that really necessary in a stadium?
Well, there is that function, but it's basically just waiting until you've connected to Wi-Fi. So if you're in the venue Wi-Fi, it'll start to do that upload.
This is not
because Wi-Fi magically works.
No, but there is another layer actually. If you look at clients have a cost model for every connection. So there's a cost model for cellular, and there's a cost model for Wi-Fi. And if you implement simple open Wi-Fi, maybe with a captive portal, the client will see that as a zero cost Wi-Fi. If you were to use something like Passpoint, you could specify that Wi-Fi has got a cost to it and the client will defer. So that is actually possible.
Nice. How often is that used? And I see Kevin from AT&T is also on the line. He could probably chip in as well, but is it used at all, like ever, or?
Oh, he actually was right. Sorry, Kevin, I wasn't taking your statement as you were writing it. I didn't see that. He wrote the same thing. But yeah, no, we said the same thing at the same time, I promise.
Yeah, we're starting to see it roll out a little bit, but it certainly isn't. It's not in the majority of venues. That a lot of them are more kind of test beds. They're trying it out, they're seeing it, but it's not. If you were to wander into a random 80,000 seat stadium in the U.S. today, you're unlikely to see Passpoint in use. We'd like to see that change, but it's not there yet.
Well, if you go into a Cisco stadium, you're going to see open roaming turned on. So the Passpoint profiles will be in use there.
One more, not to dwell on this too long, Jerry. Sorry, can I interject with one more question?
I mean, this is the dwell time, webinar. So I suppose we can dwell on it a little bit.
Just to dwell on this a little bit more. Thank you, Jerry. So question is, like, I'm sure you've metered all kinds of things and taken analytics of all kinds of things. And I know, for example, Extreme Networks and Cisco, they publish a lot of these reports about, large public venues and for Wi-Fi in general. So taking a stadium or an arena, like how much of that traffic actually is just cloud uploads versus, let's say, these more critical instant replay things that you really want to watch on the spot versus something else? Has anybody done any, like, have you guys been involved in these kind of analytics, and what's your gut feel or
yeah, so I think the Extremes analytics from the Super Bowls are probably kind of some of the best data when it looks like that. It tends to be both iCloud uploads and Google Photos. They tend to be some of the most used applications within the venues.
Makes sense.
Thanks, Chris. I will post
and you better hope Apple doesn't release a software update halfway through your game as well, or something.
We had that. So there was a club event for it was I think it was for educators, and the day before they had released the new version of iOS. Everyone was showing off their brand new apps for it, and they had only paid, I think, for a 50 meg connection for that specific location, and it was just slammed the entire time with iOS updates, so everyone could use the new apps.
There's so I think when we talk about stadiums, we think about enclosed oval shaped stadiums usually, but there's a tournament going on in the UK right now, which is very much like a stadium. It's got sloped areas, it's got raised areas, and it's got lots of concrete. And one of the use cases there is that you will be in one part of it doing something, but you might be looking at something in another part over a streaming service via its app or so on. So in that environment, we've had to kind of really consider those sort of streaming requirements, and because it's so huge, you need to almost do it on a very considered, where do you think this will happen basis, rather than I was going to put it everywhere, because that can't happen.
Very good. Let's change gears a little bit here, and let me get my screen share going again. So as far as design strategies go, which I think is kind of a good segue into that, of how are we going to approach these kind of high density stadium environments? I think the first thing is we need to approach it as a density over coverage type design strategy, right? We need to, we've moved away from that in general in most environments, but what that means is, we're going to favor, figuring out not just from an RF standpoint of how are we going to get signal everywhere, but how are we going to more do the opposite, right? Of contain that signal to do those smaller cells, right? To be able to support a higher density of users in those small areas that we talked about. So that means strategic AP placement is going to be very important. What else am I missing from this list? I mentioned things like antenna selection. Let's kind of talk through some of that. Why don't you guys kind of share, your design strategy for these high density environments? Dan, you want to start maybe kind of just talking through, just from high level, start to finish, what is your design strategy for these types of environments? What things are you looking for? What kind of requirements are you gathering? That kind of stuff.
Yeah, I think there's a couple of things to it, right? If you're adding something to a pre-existing space, a lot of the time you're constrained. You're constrained by what you can do, right? So a lot of stadium spaces won't necessarily have spaces where you can run cable through to put APs under seats, for instance. You know, so that wasn't in the design. It's concrete now. You can't just start, you know, cutting holes in the concrete because it's structural. So you know, you might not have an option. You might have to go for a very directional antenna rather than underseat AP placement.
So it sounds like greenfield and brownfield is going to have a very drastically different design strategy.
Yeah, exactly that. And you know, that's thinking about just stadium, you know, spaces. But you know, if you've got an outdoor space, for instance, where there is no under seat, there is no underground, you know, it's a crowd, it's a space that's available. You don't have the option to necessarily put an AP under the floor or whatever. So I think the ability to be able to use all of these different types of you know, putting things in, for me personally, if I can put an AP under a seat in a high density environment, that's the best way, because you can then, you know, you can attenuate that with the bodies that are going to be there. And I really like doing that. But that's not always an option, right? So then you have to start looking at, okay, well, where can I hang, you know, antennas that have got, you know, narrow widths on them? Well, I can't, because there isn't a roof on this stadium, or, you know, I don't have that option. So, okay, so now I've got to look at directional antennas coming off the hand railings, you know, in between, you know, sections of seating, I think. So there's like loads of different things. So I think the first thing is just figuring out what have you got, what can you work with, you know, talk to the team there that look after the estate and go, you know, what are our options? I think that's a really good place to start.
Yep. I think UC is kind of modeling some different, you know, kind of mounting positions of, you talk through like, you know, underseat being kind of like, I think everybody on here would agree that underseat is the ideal, right? If that is an option at all or feasible, that's the ideal. I'm curious if there's any other kind of hybrid type solutions beyond that, or is it kind of like all or nothing? Chris, what's your thoughts on that?
Yeah, so really it's about letting the architecture drive what the right mounting solution is. If you've got super narrow or short sections, you know what, underseats, you're not going to get the return on those underseats. That overheads probably work pretty well in that scenario, either overheads in front or overheads behind. You can do mixed deployments where you've got underseat in some and overhead in others, but the problem becomes when those are one on top of the other or adjacent to each other. That mixed mounting scenario, the overheads will tend to wash over some of those sections where you've got underseat APs. So that's another sort of jumping back to the start of our discussion. That's another one where you're not driving the client to make a good decision, that they've got line of sight to that overhead AP. They might see that as the better roaming option. And as always, the client makes the decision on which AP that they're going to connect to. The only thing you can do is incentivize the behavior. So you'll end up having more clients on those overheads than just the section that you're intending to cover, even if they've got a perfectly viable underseat nearby.
Yep. Yeah, so it's
something to Chris's comment there. From a client perspective, you guys know me. I love to sort of look into what the clients are doing. As you move to your seat and you kind of transition around and you're moving past all these bags of water, right? The client is making choices all the time. And it might be blacklisting something. It might go, oh, look, there's this underseat AP and it's not great right now. So I'm blacklisting that. And therefore it then transitions off to the overhead, even though you're on a perfect, like what Chris said, perfectly viable underseat directly under you, but it's off. It's out of action for whatever period of time. That it could be anything from 10 to 60 minutes.
Yeah, and you also have like the serviceability, right? Like the install cost and the maintenance cost of an overhead antenna might be much higher than being able to look after like an underseat AP that's in a box, you know, that you can easily get to, that you can swap out if it breaks. You know, there's those kind of considerations to take as well. It's really hard. It's really hard to decide how to do these things. Yeah, and I think like there's not like a one thing fixes all kind of solution here. You really have to kind of take all of these things into consideration. And I think, like I say, talking to the people that are there, you know, all day, every day that work in that environment, they're going to be so critical to understanding what your constraints are. Because you might have a plan, you know, when you look at floor plans and you have a look and you go, oh, I know exactly how to do this. And then you go and talk to someone who works there all day, every day, or, you know, you go and talk to the person who looks after that space, because you might work there, but you don't necessarily look after that particular space. And that massively changes the way that you end up designing. And to what Ben was saying as well, it's also about how people, you know, ingress and egress out of that space. You know, are you doing things to protect that client roaming decision? Are you putting APs in certain areas to help with those transitional moments, you know, as people go from like the concourse and the vomitories into that main bowl? Yeah, these are all things that you have to kind of take into consideration. And I think where you've got, you know, so if you've got areas where you've got people that come back to a space all the time, you'll notice that, like in a football stadium, for instance, areas where you've got season ticket holders, so people that go to every single game in that stadium, your associations in that area are probably going to be much higher than, say, the away fans section of the stadium. Your associations will probably be much lower there. And so again, that's something that you'll have to take into consideration when kind of planning these things out.
Hey, what about like Jerry, request permission to dwell?
Acknowledged.
You're supposed to say granted, aren't you?
I'll give you a block. I'll give you a block acknowledgement.
Thank you so much. So what about the crowd impact? Because here we can see like it's massive. The crowd impact is massive. Like if this is an underseat AP, and you know, depending on what I'm doing, like how I have the crowd set up, if I disable the crowd, just gets massive. Like of course, like a stadium looks totally different, like empty versus packed, especially with underseat. I mean, with overhead, there's actually isn't that dramatic of a difference. Did I have an overhead AP here somewhere that we could look at? Maybe this, no, maybe this guy here. So with this guy, I don't think it's gonna make that much of a difference. So if I disable the crowd, enable, I accidentally also, well, anyway, it doesn't make that much of a difference. So what is your take, and do you like disable some of the radios for you know, for a half empty or empty stadium? How does this all work?
So actually I wanted to bring this up as one of the first things, actually, because we find ourselves troubleshooting stadiums where they're being given a different persona to maybe the single thing you might install for. So today, a lot of stadiums will have 3 personas. They've got the primary sport, so might be soccer, might be baseball, might be whatever. They've got a concert mode where you've got a ton of devices on the pitch, and potentially some empty seats. And then they've also got some kind of usually half full scenario where it's a youth game or something where it's not filling it. And so I think in the requirements capture to that point, you know, you really need to sit down and say, well, what are these operational modes, and almost actually create configurations and have an operational manual that says, well, today we're in this mode, today we're in that mode. And that might, you might always set for a concert, you might always set the stage up in the north side, so you turn off the north stand, and that just is something that happens. If you are only half filling the stadium, you might turn it down. If you've got a lot of devices on the pitch, you might need to alter some probe suppression around some of the lower APs or so on. So there's a lot of tricks you can pull, and we'll get into this, I guess, down the line. The key to this is that you've got to engage the vendors, because there's so many knobs and dials around this stuff that we can sit here and talk about the principles of it, but actually how you get those different personas to work is very much a vendor's job in this environment, I think.
Yeah, and understanding what those personas are going to be as you're starting to design and build and configure this, because it can be relatively straightforward either to script, or maybe it's just a manual change if you've grouped your APs together and your manufacturer of choice allows you to make those changes in bulk just to a profile. So you might group all of the north stands together, so you can just disable that device group easily. You might do northeast, southwest, so you can do those individually depending on where things are set up. You might have that first row of lower seats. If you're going to have to make probe suppression changes, those might be ones that you change, kind of group into their own device group. But then you start to get into, all right, now I've got 100 or 200 different device groups, and if I need to make a change, am I managing all of those individually, or how do we do that? So you want to understand what you're going to be doing, and then try to get that configuration to be organized in a way that allows you to both easily do it, have the granularity that you need, but also make sure that you're not you don't have an unmanageable number of groups or profiles that you have to touch every day.
It's not only that, is your monitoring needs to adapt with it. So if you're turning off a bunch of APs and changing a bunch of things, then your operational metrics are changing. And so if you've got alarms going off because something's not right, it might be right for that persona that you're in. So you have to change configuration, you have to change the monitoring. And you need to also, if you're doing sort of live testing of any type, you need to understand your persona and know what you're looking for, so you can actually really sort of troubleshoot these things.
There's a lot of manufacturers that have monitoring solutions that basically let you know about differentiations from baseline. And if you've got a venue that's not used every single day, guess what? Every event is a differentiation from baseline. So those reports that you're getting, those alarms that you're getting, they're all absolutely useless. You know what? Guess what? The channel utilization is going up. Sure thing. There's 80,000 people here now, and there were 100 people here this morning. That's expected.
You see, there was a question around the attenuation for the I guess the crowd attenuation, the seating from the seating itself. Well, I guess, yeah, maybe I'm not understanding the question right. Vince asked if modeling the slope in crowds are great. Okay, so he did get the crowds piece of it, but he's wondering if we model the seating itself. So the actual physical seats, I think, is what he's asking for there. So I think that's kind of factored in, right, of the attenuation that we're modeling of the crowd is also taking into consideration the seats that would be part of that.
Well, exactly.
So yeah, but the only thing I'd say is that.
Oh, go on, Dan. I think you're going to say
Ben.
You do it.
To the point of the concert that's being kind of set up in front of us, some of these stadiums will take out seating because they need to have wider ingress and egress from the pitch, and so they'll take out like a corner of seating. And that now is basically just stairs, right? And so again, it's back to that kind of knowing how they're going to set up an environment for each of these different things, and being able to make sure that you've modeled it and that you know how to test it, and that you kind of know what's going on, because you can guarantee that if you hand that original kind of design file to customer, they're going to think that one thing is going to work no matter what they do inside the stadium. And again, as part of your requirements capture, making sure that you've had those conversations, you've said, like, give me every kind of configuration that you have, because they'll have them, because they have to submit them for plans. They have to, before they're allowed to do these events, they have to get these things signed off, right? So you should be able to get that stuff and actually have those conversations with people.
So the other thing I was going to add was your starting position is nominal, right? So you're starting from a nominal position, which is based on an immense amount of learning that each of the vendors have done. So they say, we've done stadium after stadium, and we know that if we put one AP per 75 people on the seat, or something like that, that's nominally right. And your starting position will be, whatever power level they recommend, depending on the APs they put in, the antenna patterns, so on. But then you've got to tune. So, okay, surely the people and the bags of water that we're talking about here are going to be more dominant than the seats, but there may be exceptions. So it comes down to a number of test events over which you validate and tune that design. So you might say, okay, well, now I need to break this area down into a number of zones, and those zones could be sort of decided for various reasons. But one of the reasons might be, I've got premium seating here. It's quite different. And so as you walk around, do the test event, you might up that area by a dB from one event to the next, and then test it again, just to kind of make sure that it's taking into account some of those environmental nuances. You don't know exactly what has happened over the life of that stadium. It's a very old stadium. There could have been other things done underneath the floor or so on that might affect something.
You see, there was some questions around, what it is exactly. You want to just kind of talk through, what it is that you're modeling here. I know you're trying to kind of depict what we are, talking about, but yeah, you want to just kind of talk it through for people who aren't familiar with, Hamina and some of these features and stuff that you're working with.
Yeah. So good question. I just quickly modeled a stage on the stadium, because as we can see, that impacts the signals a little bit, like what happens behind the stage. The stage is blocking a little bit of the signal, stuff like that. Certainly, if we put APs behind the stage, it would have an impact. But what I was just doing is I just put a crowd here, or like a capacity area of a couple of thousand devices, and then I just started putting like APs on Wi-Fi stands and trying to understand like how would the associations go. I put some Cisco 9166 D1s, which is a directional 6 GHz capable AP. I put in some Aruba 615s here as well, and just kind of started to, like, these are omnis and the other ones are directional, and just poking around, like, how would they associate, how would the clients associate to these radios. We can see, for example, here that, with today's maybe Wi-Fi 6E adoption, we'd have 1,800 clients on 5, and then we'd have a 250 on 6 and stuff like that. And here we can see the individual AP association count. So on channel 149 on this AP, the 5 gig radio would take 170 clients. This guy would take 113. I was trying to adjust the power levels so that the APs wouldn't, and down tilt, so they wouldn't like massively. The D1s tended to dominate because they give such a huge directional beam towards the stadium, of course. So I pointed them down, started reducing transmission power, stuff like that. But what's interesting is even here we can see that this massive guy just blasts throughout the stadium, and there goes that channel for more than half of the stadium. Granted, we could put a little bit of crowd here. Also I have crowd on the slopes, but I do not have crowd on the station or on the green. What is this called again? On the field or whatever you call it. So I could put some crowd there as well. And let's see what that does to the signal. Not much difference because the crowd was so low. But yeah, it actually helps. It helps to some degree, but yeah, it's still like, because the APs are above the crowd in this case, they still blast over it. So much for that idea.
those are at 15 feet, but we tend not to get approval for APs that are mounted that high on the side unless there's no seating behind it. So those tend to
That's
have to
right.
be much lower if we're doing kind of from the edge coverage. So if that goes down to
And
like
maybe
6
it's
feet,
actually better that they are lower, because then the crowd will, block
yeah,
those
so
signals
it'll be
and
lower,
kinda-
but you likely won't be able to get to the center of the field for fan coverage, depending on the crowd density too. So you'll usually have to do
True.
some sort of combination of mounting, and whether it's stage, whether it's at the audio and video booth, whether it's from the walls. There might be like point of sale concession stands throughout that you might be able to utilize too.
Yep. If it's
That's when
if
they
it's an
send the Wi-Fi
arena,
engineers to walk or like hold APs up as part of the crowd, right? Sorry, Jerry, go ahead.
if it's an arena, you can use the center scoreboard. I've used that before for APs and antennas, especially directional antennas in there. You can have a nice spot right in the middle then to hit over the top of the floor.
Yep. Yeah, those can be really good mounting positions as well, but a lot of modern arenas, that center scoreboard lifts up and down. So depending on the scoreboard configuration, you might actually have to change the angle of those per event if you're mounting there, or if it's in a lower configuration, it's probably either a basketball or a hockey or event. And so you may not even need those in those scenarios.
And in our UK stadiums with big open roofs, we don't really have that option a lot of the time. It's an interesting one though, because the minute you put people on the pitch, if you don't give them something to connect to, you just have probes in the air going crazy, and it just really does impact the overall surface. So you end up having to do other things to kind of trying to do that. And I did read one vendor had almost like a solution that you could deploy to trap probes. It would just mimic what something was probing for and say, yeah, I'm that, and then trap the device so it would just shut up.
Isn't that the Wi-Fi cactus?
A bit like just walk around with that.
No, that's IPS.
Well, to kind of bring things back, I've got a couple other slides here. So we kind of talked through a lot of this stuff already, but just to kind of visualize what we're talking about here. So these are some of those kind of strategic AP placements that we're talking about. If you haven't seen these before, that underseat one in the top right, that's the one that we're kind of talking about in, at least I would say in more modern type environments where it's new construction. That's kind of the ideal solution, right? That puts the AP very close to the users, really, right below the users or right next to the users. So I'd say that's going to be the most ideal. Would you guys agree? In most cases, that's what you're kind of going for, if that's an option.
Yeah, tends to be if it's a large enough venue and there's long sections that it's certainly the most expensive from a construction perspective, but yeah, usually my recommendation for larger venues.
Right.
And I mean, certainly in greenfield as well, if it can be implemented into the castings, that's obviously good. But there's a stadium that Real Wireless just helped with in the north of England that did core drill everything, and
wow.
That was a big project, but it works really well, really well.
Nice. What about some of these other solutions of overhead and handrail? And then we talked a little bit about like the center hung and some of the caveats there. What any other comments on any of those options?
Yeah, so handrails, they are viable, but you are again at the mercy of the architecture. So if your sections are 50 seats across, you're not penetrating in the middle with a handrail antenna. So it's not really viable for that solution. Same thing with the overheads. I've used overheads a lot. I like them in a lot of scenarios. But if you've got a very deep section, that's another one. You have line of sight, but you're not servicing clients effectively down at the bottom 5, 10, whatever rows there. So you really just have to let the architecture drive the decision on what the right mounting solution is.
Any reason to consider like a handrail plus under seat, or if you can do, a handrail, you can do under seat, so might as well just do all under seat?
Yeah, so if you're talking about mixed for handrail and underseat, if you've already been able to get one underseat AP out there, there are options for you may only need to do one core to a single location, and then you could do like flex conduit up under the seats to get to the other location if it's within the same section. So you could also do tracking along the riser to get that cable over to the other location. So tend not to do mixed handrail and under seats, but I wouldn't say never. I wouldn't say I'd never do it again. It's one of those. All of these locations are unique, and you have to treat them as unique. You can't just say it's underseat everywhere. Underseat's going to work for this one. That they all have unique requirements. They have unique ownership groups. They've been they have all of different ages. Some of them you might be able to core in. Some of them you might be able to track in. Some of them you can't do anything underseat just because of health and safety. Whoever runs that in that municipality, they might say, nope, it's a tripping hazard. We can't do it, period. So you got to look at each of them individually.
I think in the UK, we really don't see handrail very much at all. I don't know, actually don't know of any myself. But one of the things I was going to say, a lot of the kind of the difficulties of underseat there, but just to kind of balance that message a little bit, some of the difficulties of overhead, we do have quite a few stadiums with really low roofs that are, the glancing angle is right in front of you because you're intending on looking down at the pitch, especially if you're high up. And whenever you then add some kind of hanging strut to hang APs off, and Wi-Fi is not even the worst of it, it's when you put DAS up there as well, that you've got these visual obstructions now to deal with. And so another scenario would be a very popular tournament that's on right now has both an extremely old concrete building and very, very low roofs. And so how do you even do that? It's actually quite difficult indeed to do it. And it's one of those situations where there's probably no right answer, but a lot of trade-offs and a lot of balancing. And everything will cost a lot because it's going to be a difficult one. I think what we are seeing, though, in terms of something that I don't see here, but it's happening a lot. So Tottenham Hotspur Stadium is an example of it, where newer builds, where especially with cladding and so on, with the antennas are being actually fabricated into the structure of the building, and they're almost invisible and hidden in plain sight kind of idea. And so if you can do that in sort of roof spaces where you would typically find slight indentations or perturbations for speakers, you can do the same for Wi-Fi. Those type of approaches are often going to be worth thinking about, especially where aesthetics are important.
That's a good segue actually into the next slide I had on antenna selection. So we've got multiple options when it comes to antenna selection. Are we going to use integrated versus external antennas, omni versus directional, or a narrow versus wide beam? Thoughts on this one? When are you going to use one or the other? What kind of drives that decision?
Sorry, I was reading the chats.
Dan, you want to take that one? What's your thoughts on antenna selection? When do you choose one versus the other? What kind of dictates that?
Yeah, I think again, with this stuff, it's for me a lot of this is about actually testing these things. So going and putting an antenna somewhere and looking, how does this affect this actual space, right? And going to spaces that have already deployed something and just going, hey, do you mind if I walk around? Yeah, I've done that before. I've said to places, hey, look, I know you've got this solution. I'm a wireless engineer. I'd love to just go and see what you have and why it's, how it's working and things like that. And getting your own stuff, right? So just having, I've got antennas on the floor down here that are kind of ready to go and to put up somewhere and test and have a look at. And you know, in a lot of these places, you've got every stadium is completely different. You know, you walk into one space, it's gonna be a completely different space to any other. And like you say, even within that, you have areas that are different, that are catering for different needs. You know, you've got the concourses and the stuff kind of below the kind of bowl, that's going to work very, very differently. And it's still high density, you know, because, you know, when the match isn't on, they're all in the concourse getting their pie and their chips. Well, they are in the UK, and their beer and, you know, stuff like that. So, you know, what you would do out in the bowl is going to be very different from what you would do in those kind of concourse areas. And again, those concourse areas are going to have very different roles within that space. You know, thinking of a stadium that I've done recently, they have kind of designated, you know, drinking and social gathering areas, and then they have more kind of transitory spaces as well. And so, you know, you're going to use, you know, omnidirectionals in some of those areas, and then some of those kind of denser areas, you're going to shower down directionals, you know, directly down, you know, to cover a smaller area. Yeah.
Maybe what we should do is have UC model. We've been talking a lot about like the underseat, and I'm assuming with underseat, you're probably using omnidirectionals. Is that right? Just an integrated omni.
Yeah.
So let's see what that
tend
looks
to be cheaper
like
as well.
Yeah, and you probably have you've got a very small footprint, as we saw with the that small box. You know, you're going to put the whole AP antenna and everything in one. Yeah, I don't know. You guys have any other strategies with like underseat of using some type of external antenna or anything as well, or is it typically all in the box?
We've tried in the past with some externals, I think very early on, and just did not see the return on investment, whether using 120 degrees facing up or 180 degree facing up. Functionally, once the people were in the seats, it was a very similar pattern. Anyway, so
what would it be,
ruggedized,
Chris? What would be your AP of choice here? Sorry to interrupt.
So for underseat on the extreme side, it'd be a 560i.
560i. And then we kind of flip that on the floor, pointing up, you said, or?
Yep.
So yeah, there we go. What about transmit powers typically for something like this?
IR or EIRP?
IR.
This is from the radio, excluding antenna.
Yeah, IR, a pretty good starting point would be about 12. You're probably a little high, but this is one of those ones where you throw these out, you deploy all of them, and it looks like absolute garbage when it's empty. That you do some of the surveying and validation just to make sure all the radios are on and transmitting, and they put the right AP with the right name in the right spot. And then the first event is that really big tuning exercise where you get bodies in the seats. You get to survey up and down the aisles. You might be able to get into a seat and do a little bit of more in-depth testing. But then that power level, you fine tune it based on what you're seeing from those surveys. So it's a starting point, not necessarily what it's going to be for every environment.
Show that again, UC. So UC was flipping between, as Chris was kind of talking there. I don't know if everybody followed that, between what the crowd attenuation. So this is representing, as far as the crowd attenuation, this would be every seat filled kind of thing. So that's empty stadium at the same power level. No adjustment to the power level, but at the same power level, if that stadium's empty, and if you zoom out, you can probably see that signal is basically covering nearly 100% of that stadium, right? That's one AP in there. And then everything fills in, and talk about a scalable kind of environment, right? You need this thing to be very dynamic in that sense of changes very, very drastically as the stadium fills in.
And this
that would
is
be
what we were
full.
saying about having the personas for the different types of events, right? So if you've then got, you know, hundreds of APs behind the stage that now don't have people sat in them, you're going to need to have a plan for what you're doing with those APs, because otherwise you've now got 300 APs that you can hear over the entire stadium, right? Just because there aren't bodies sat on top of them.
Yep.
Yeah.
What do you
yeah.
what do you guys think
And
about this?
what I
coverage?
found, sorry.
Oh, go ahead,
Go ahead,
UC.
Jerry. Go ahead.
Oh, I was just gonna say, what do you guys think about what UC just did here, where he lowered that crowd attenuation to kind of represent, you know, not full stadium. So this would be kind of only so many of the seats are kind of filled in now, maybe half or so. Does that look what you would expect to see as far as the coverage of kind of maybe a half full stadium?
I wouldn't look at it that way personally, because I mean it's useful, but I think you're going to get a ton of reflections and the odd kind of RF is just going to be, you know, RF, right? It's not going to be circular like this. So when the stadium's half full, it comes down to the expertise and knowledge of tuning, probe suppressions, all those kind of things. It's not about maybe looking at it this way, I don't think.
Yeah,
I think
it's like estimatory at best,
Yeah.
as always. Like how much is the crowd gonna affect, and like, you know, where is the signal gonna reflect? What I did find interesting was this, like even if we feel this with people. So if you actually, I don't know if you considered or looked at this, but if you put the APs on the front rows, they actually start bleeding out into the edges more. And this makes a lot of sense. So if there isn't a lot of like people in front of the AP, it will likely start leaking out. If you place the AP kind of in some of the front rows, which are typically empty anyway, they're the most expensive seats, but the rich people might not even show up. But this is what I found, just like a nice curiosity.
Yeah, so in that scenario, you may want to be tuning those lower ones. You want to be tweaking the probe suppression a little bit more. You might be doing slightly different power in those areas, but it's unique per environment, because a lot of older venues, that railing is actually poured concrete coming up right in front of the client. So you'd have a wall of concrete in front of the AP, blocking some of that signal going into onto the field.
True.
If only we had a way to model that.
Yeah. Hey, we do.
Does anyone know a tool that does that?
Yeah, like walls, modeling walls. That would be crazy on a wireless tool. No way. I'm just gonna put a concrete wall right there. I'm sure this will be fine, right? There we go, without adjusting any heights. That should do it, right? Let's see.
It gives us
Hey.
Nailed it.
Yeah, Jerry, you mentioned about placing APs, like, you know, in front of the audience. How's this concrete wall?
That's beautiful.
Slightly obstructed view ticket,
Yeah.
$12.
Yeah. Exactly.
Hey, but the Wi-Fi works great now.
Yeah, exactly. That's how you do spectrum reuse the right way.
Real quick time check. We are just about at the top of the hour, so I want to make sure that we get through some questions and stuff here. So if people need to drop, we'll continue on with some Q&A here at the end, and have those recorded. But appreciate everybody for hanging on this long.
Well, there's one question I had said I would take in the chat here. It was just about different devices, and seems we're talking about antennas. There was a question about why do we model different devices in the capacity planner, and what I think somebody did say, different antennas, different roaming profiles, different selection, but different antennas as well. We've got quite a variety in terms of size of devices and so on. But I think one of the things, and maybe this is a feature for you here, UC, but in somewhere like a stadium, especially on a particular, like a concert night, people might turn their device into low power mode because they need it to last. and then the spatial streams are going down and your connections going down, and it affects your MBR and it affects everything. So it might just be, you plot association areas, they change because of the devices, and that's kind of why we model different devices, but different devices have different modes too.
Very good point. Very good point. But yeah, in our case, it's typically like the most dominance is kind of the logic, like you said, using which the client device associates to the network. How much does it prefer 5 gigahertz or 6 gigahertz over to 4 and things like that? Those are really the
yeah. And testing these things after you've deployed is so important, right? I think a lot of times people kind of shy away from it because they're like, well, they've paid for it to be installed now. Well, yeah, but they've also paid for it to work, right? So so if we do need to make some changes, that's okay. Go back and make some changes. Like, no, like from doing these things, it's very difficult to get this right perfect first time. Even when you've done a bunch of them, there's always going to be something that you can kind of go back and make better and work on.
Yeah, particularly for new construction ones where you start this process and a building doesn't exist yet. You've got some plans, what the initial finishes are going to be, but then you show up and it's like, oh, that wall that was just supposed to be drywall, you know what? We've cladded it with teak on either side. So that's going to change a little bit how things were happening in that suite space. So yeah, looking at it, testing it after the fact, and then talking to the customer that these are big projects that most customers understand that if you've got to tweak something in one corner to make it right, that's what's got to happen. They did pay for it to work.
I think another thing that is kind of important is revisiting at some point down the line, because it does tend to be that there's parts of the stadium that are not quite finished in new builds, and Wi-Fi gets put in, and then things change purpose over some time, and you find that what it was good for in a suite back a year ago is no longer the use of that suite, and so you might need to adjust that, change that. You might have had a directional and now you need an omni, or the other way around.
Very good. Well, that takes us to the top of the hour here. We do have some questions that are open. If you guys have a few minutes to stick around, if not, I understand. But yeah, if you guys would stick around to try and help us answer some of these questions here. The first question I've got is from John. In targeting per seat, how about open standing areas instead of targeting per seat? What is a good person to square foot gauge to use to target against? Any thoughts on that one?
So it really depends on the space. I think that if that is a ticketed space, you will have an understanding of how many tickets they're going to sell for that. So you're going to know what the maximum number of people that are going to be in there, plus a little bit of margin for the workers that are going to be in that space. That's the metric that I like to use if I can get it.
Okay.
But so knowing the capacity of people is great, but it's the use of it as well. So if it's a bar with TV screens around and all that kind of stuff, and people are not going to be really pulling out their phones other than a quick message, you can associate 200 people per AP if you want to. But if it's somewhere where like a VIP area where you think there might be, there'll be business use when it's not even on a match day, right? Sometimes, or even on a match day, and there'll be all sorts of different uses. You might want to just get down to your more sort of office environment. You might want to get to sort of 50 people per AP or something. I tend to start with 100 and then ask the customer and kind of go from there, whether it's a bit up or a bit down.
Yeah, it's a good question around I'm thinking of the specifically the person per square foot kind of rule of thumb, I think is what he's looking for there. And is there something that we use to kind of calculate that? But yeah, I think what you had mentioned, Chris, around like, if it's a LPV, large public venue, and they have open spaces, there's going to be a limit to, how many people, for fire codes and stuff like that can be in that room, that space. Hopefully there's some things like that you can also use.
Yeah, I don't have a defined this many people per square foot, but one of the things that I have found useful recently has been there's a lot of these kind of like AI cameras that are like counting how many people pass through a space in X number of time. I've been able to use things like that recently to kind of get a better understanding of, okay, what are we seeing in terms of actual people walking through this? That I find that helpful.
Yeah, it's interesting too.
There was a piece of academic research that I used in a project recently, which attempts to convert flow rate. So if you've got scanners or ticketing scanners or something like that, convert flow rate to potential density. Obviously, there's a lot of factors in that, but you can do a kind of a rough order of magnitude. So, if you've got, say, 60 people flowing through per minute, you might expect 2 to 3 people per square meter on the other side of that, because they have to, depending on how free flowing your space is, and you would look at that. But yeah.
Michael had a question. This is a little different than some of the stuff we've talked about, but around monetization and the Wi-Fi infrastructure. If you guys have any kind of tips or suggestions around interesting app integrations, analytics, location, that kind of stuff, any projects or anything stand out to you guys that you've done any of that kind of stuff with?
I've got opinions on this one. So there's different ways to monetize. That there's direct monetization where they're paying for the service. Think classically more hotels, premium internet tiers, that kind of thing. And then there's indirect, where the business is getting information that they can then use to either make better business decisions to drive higher margins or higher profits, or just getting entries into like the CRM. So there's multiple ways to do this. The biggest that's sold right now is things like captive portals. That's where you might have to do Facebook, Twitter authentication, or you're putting an email in. I tend not to like those. That they're I think every captive portal is a barrier to entry to get onto the Wi-Fi. They tend not to be great user experiences. Depending on the timeouts that you've got configured, it might be in your pocket and then you have to see that again. But that gets an entry into the customer CRM, and they know the dollar value of that. So it's a hard conversation to have with them when they already know, well, even if we get half the number of users that connect or a quarter the number of users that connect, if I get 5,000 entries into my CRM, like, here's how much I'm making every event. So it's tough to have. The way I prefer to do it is some of the stuff where they can reach out directly. So it might be a venue app or a team app that you get better data about the user. You can reach out to them in more ways than just being 100%. At the venue. You've got the ability to elevate the user experience as well with things like live streams or different camera angles. And it's a better user experience on top of that. It's just already on your phone. You can connect to the Wi-Fi. You don't have to touch anything. If you want the app, great. If you don't have to do it.
Nice.
Yeah. And a lot of these places have, e-ticketing now that would be done through an app anyway, right? So, just bundle all that in. That for me, that's the best way to do it. Have an app. You could do, indoor mapping with that. You could do all this stuff and still get the marketing thing and make the Wi-Fi nice and easy to connect to.
Yeah. So the Wi-Fi and the cellular is your foundation of that connectivity, and then the app can be your foundation for other ways to interact with that customer.
Yeah.
And there's a bunch of companies that make either lightly customized or full customized venue apps, including maps, including those live video feeds. That there's companies that do that exclusively.
We got a real. Oh, go ahead, Ben.
The other thing, very quickly, there is good Wi-Fi is about minimizing friction. Captive portals and all that kind of stuff are friction points. If you go down the app route, you've got the ability to basically engage a user on create an account with us. We'll get you seamlessly connected. We'll do all those nice things. Passpoint, open roaming, whatever it might be, can all come into play. I'm confident we'll see more of that as we go down the line there.
Yep. I really like this question from Gustavo. How do you do a validation survey on a stadium? It's hard to survey the rows with paying customers already seated and trying to watch the show and game. So yeah, I know I know that one kind of firsthand. I'm curious if you guys have any thoughts on that. Is it a no-go? Do you have a solution for that? You know, what do you do? How do you validate this? You know, easy to do in an empty stadium arena, right? But you know, how do we validate the coverage and stuff like that when it's actually full?
I know a really good way. You walk around with your iPhone, and then you take the logs from your iPhone and you open them in an app called N Oversight, and it will tell you. I had to do that for you, Ben. Sorry, but that's what I do. That's how I do it. I will walk around with my personal iPhone. No one knows that I'm surveying, and then afterwards I can export the logs, open them up. You know, when I save the logs, I'd say, you know, I walked this section of the stadium. I upload it to Dropbox or whatever, get back to my laptop, open those logs in N Oversight, and I can see everything.
I was going to ask permission to self-promote, but thanks, Dan. Doing that.
That's actually a really good one, though. I mean, that way you don't have to be, I guess the tricky part is, you know, how do you correlate some of the location stuff with it? But yeah, I mean, obviously you can collect a lot of data without interfering with the event, right, and getting in people's faces or in people's ways or anything, or their view. Yeah, I think that's a really good
and
one.
You're getting it from the device that people are using as well, right? You know, I'll stick it in low power mode and I'll do what people are doing, and then I'll go, yeah, you know, this is how it will work for people that are in that space.
It comes back as well, like in Hamina, we can put the association zones on, so we kind of, if we move our roaming man around, we kind of know where we expect things to happen. And then if we take a real device and do that, we can validate our design as well as the performance from that device perspective too.
Yeah, but in any scenario where you're validating that you're not doing the whole venue in the seating, that it's just not possible. You're defining specific example sections that are likely repeated. So it might be, you might be getting 2 corners from one side and a couple of rows, or sorry, a couple of sections from the middle, maybe some of those premium areas, but you're not doing the whole thing. And then if you can do at least some testing with an actual device that's going to be used like an iPhone, you can define those test points. You can correspond that location to a time. You can look at the logs that way. You could validate it using the what developer, what's that called, Dan? The developer profile.
Developer profile.
Yep, you can validate some of that and partner with someone that's looking at the controller and saying, all right, you're associated to this specific AP at that location. Here's the performance that we're seeing for it. The client's reporting its own performance. You note that down and move on to the next section. There's options with things like air checks where you can have test points. You can download that everything that client is seeing. But again, it's not the client that's actually going to be doing the data. It's just a test client.
One thing I really think is worth bringing up here is that absolutely you need to do those spot validations. Everything Chris said, 100% you have to do. One of the things we do at Real Wireless, and we make sure that the customer does for themselves, is that user testing using a real device in a way they can understand it. And the reason for that is because inevitably, right, there are gaps. You've put 1,200 APs in a stadium, you'll still have gaps in staircases, somewhere in the vomitories, you know, you'll have that. And I think it's extremely important in the validation process to develop what we define as user journeys. So a journey of a user arrives at a stadium, goes through a ticketing booth, goes to the concourse, buys a beer, goes to their seat, you know, and takes this path. And you do a couple of spot bits like this, because guaranteed 100% a VIP or an executive or something is going to do that, and they're going to say, yeah, but it didn't work. I was standing here and something went wrong. And what we tell all of our customers is, if you do this and you log this and you say it did what it was designed to do, yes, it cut out here, but that was actually part of the allowed design, that was okay, but by the time I got here it was fantastic again, and you get that and you log that and you capture that and you present it back up to your board, then, you know, if they come back and go, it didn't do this, you say, well, was it within these parameters? Yes, it was. Well, actually, we're happy.
I see we've got a question around differentiating the iPhone and Android clients. Since Ben is our client expert on the line, Ben, do you want to kind of talk about why do we differentiate in the tool when you look at like the client view, the roaming man, if you will? You know, why do we differentiate different types of clients in there?
Yeah, we covered this one briefly earlier, which is there's different roaming algorithms, there's different antennas, different potential spatial streams, number of antennas, locations of antennas, all sorts of things. You know, to put it simply, a tablet is different to a phone. We can see that, and we can actually understand that quite easily. Take that into a smaller scale and just think about rearranging those antennas. Two phones are not, or two models are not the same. Then there's the client logic. So you know, we quite clearly know that an iPhone will start looking to roam at next 70 and you know, all these different things. Android phones, depends on the manufacturer. Samsung will probably not be the same as a Pixel in terms of where it roams. You've also got switches and dials that you can turn on in terms of how aggressive they roam. Yep. So there's new things come out. The latest Samsung UI, I can't remember what version it is. I saw an article on it recently. Is going to allow you to see a lot more of this stuff and potentially change some of those parameters as well. So it's going to get even more complicated with more layers. So you at least need to look at the basic logic of the different devices, though.
Yep. I would say one other thing too is there's Wi-Fi 6E Android devices. There is not a Wi-Fi 6E iPhone today. So that's one other differentiator, is you do have the option to toggle if you want to model a Wi-Fi 6E capable Android device. You do have the ability to do that with the iPad profile. It does also support the Wi-Fi 6E iPad to model that as well.
And it's good that you can set the number of those that are 6E capable, right? Because you know, we've got lots of companies that we work with where they're deploying MacBook Pros, they've got a 3-year kind of cycle. So we know, right, okay, you know, you're going to have, you know, 10% of your laptops this year are only 6E capable, but we know that in 3 years' time, you're going to have 100, and you want this design to last longer, right? So let's show you what it will look like year 1, year 2, year 3. And we can kind of give them those things and go, like, this is how it should work. This is how things are going to play out on your network over the next 3 years.
Brian Ward did ask around the crowd toggle, which I don't know if he asked that before we showed it, but he asked about the density slider of representing only like a 50% of the seats filled. Not specifically that, but what you can do is set the dBm attenuation for that crowd space. So that was how we were kind of playing around with that in the demo, was adjusting it down to like 1 dB per meter, which would represent, you know, fewer seats being filled, and, you know, something more like 3 to 5 dB, as in like every square inch is kind of filled with a body and a seat and everything. So yeah, you can kind of adjust for that or account for that to see different scenarios of what it's going to look like if only half the stadium is full. Another question here, considering the big amount of Wi-Fi clients, and many of them are IPv4, IPv6 dual stack enabled, do you have any recommendations from your own experience on how large should be the layer 2 domain, let's say for a stadium with 45,000 seats? So I'm not sure if anybody on here is able to answer that one, but that's going a whole other direction.
I'll take that one if we're good. So the important thing to remember and kind of separate your brain from your wired like CCNA learning on the size of that broadcast domain. In public Wi-Fi, we are for the most part blocking user to user client. If we're not using multicast, we're blocking that at the radio as well. And we're even doing things like we can do broadcast to unicast in addition. So the broadcast domain size is way less of a concern on Wi-Fi when you're taking those actions than it is on the wired side. So there is no problem with doing just a single large public VLAN and having it be sized in a /16 or /15. That's at least for V4, like that's fine. There's no problems with it. There are mechanisms like topology pooling where you can have multiple VLANs that get assigned to can get assigned to that public SSID, so that way our clients are spread throughout it. But depending on how it handles the placing of a client into those pools, there may be scenarios where a client would do an L3 roam between those two VLANs. So just understand what that specific manufacturer does for that algorithm that places them in the VLANs.
Very good. I think we just have two more questions here. Ali asked, need more options for the wall height. I'm not sure if that's a question or a statement. Maybe you can clarify that one, Ali, of what exactly options do we want to add for that? But
yeah, was UC's couple 1,000-foot wall not enough for you?
Hey, you mind if I step in for this, Jerry?
Oh yeah, please do.
We will be improving the wall height stuff where you can more flexibly kind of set the upper height of the wall, but also the lower height of the wall, so you can do floating walls and walls from the ceiling like more easily and stuff like that. So absolutely, I think this might be what Ali is referring to, because you can only select like height from floor, or if you click the floor, it changes it to height from ceiling, but you cannot do this like AC ducts and then put John McClane to in those and stuff like that. So I think that's it. Jerry, do you mind if I actually show one other thing as well? For those that stayed on for this long, I think they deserve a treat. Is there anybody on the line anymore? Maybe there is.
There are a few. They may have fallen asleep, but there are a few people that are still tuned in.
Excellent.
I need to go, so I'm going to watch this one on the webinar.
Thanks,
you're
Ben.
going to miss such a great...
You stayed on this long and now you got to drop.
I have to. I'm already overdue.
Thanks, Ben.
All right.
Appreciate it.
See you, Ben. I'll just quickly show this. I don't know if you knew this, Jerry, but for the roaming man, you know how the W can turn it into a walrus, right? And all that. However, if the roaming man gets too close to the edge or like this edge of a building, oh my gosh, he gets scared.
I did not know that one.
Yeah, man. It's just like you get too close to the edge. And he gets scared.
You didn't make that into a Hans Gruber to fall?
Yeah,
missed opportunity.
Hold on, by pressing G, you can get. That's our Christmas themed Gruber, and if you press F, you do get the Gruber falling as well. Anyway, yeah, just wanted to provide you with this important announcement before we depart. Anyway, I'm out. Thank you, guys.
Yeah.
Thanks so much, guys, for joining. Thanks for the audience.
We had one more attendee still on. Germund, you want to say anything?
Yes, I can. Can you hear me?
Yeah, we can.
Yes.
Thanks for
Hey,
joining.
Germund.
Okay.
How are you?
Hello.
Thanks for joining and staying on this long.
Yeah, I'm sitting on my terrace and looking at both you and the beautiful view of my village.
Is
Awesome.
it your village? Do you own it, German? You're the king of the village.
Yes, I'm agree.
Excellent.
Well, I think we can call it good there. I think we've pretty well wore this one out, but I appreciate everybody staying on this long and helping cover this topic, especially to our panelists, Chris and Dan and Ben. Really appreciate you guys hopping on to help us out with this one.
Thanks,
guys. Hey, and let us know what you thought about this on LinkedIn or Twitter or anywhere. We're desperate for attention and stuff like that. German, how was the webinar for you? Not technical enough, obviously, but other than that,
Yeah, it's good enough. Of course, it could be more technical, but then we use another percentage.
I strive for good enough.
Yeah, I'll take good enough.
We'll take good enough from German. Excellent. And one of these days we'll have a German focused webinar where we'll go like super deep into some. I will of course not be on that webinar, but we'll invite guests who will go deep enough for German to the bits and bytes.
Okay, good luck.
Oh, we did have one more question. Looking at on-site measurements you have to use to determine slope, and if you need to calculate AP height from floor or from slope setting. So I think that's in relation to the first question here was around how that determines the low and high measurements on the slopes. I don't know, Jussi, if you have any kind of thoughts on that of maybe that's with the grade of the slope and the attenuation.
Or was this like, what is the like AP height and client height in relation to the slopes? So we thought about this quite a bit when making it. And for the slopes and raised floors, the AP height is always like in relation to the slope. So if you put it, or raised floor, if you put it to 0 meters, it will be right at the slope. It will be right on the floor. It will then get up to the raised floor here. So it's always relative, so you can easily kind of move APs around and it will still stay the same. This is how we figured, this would be the easiest to use. But then if you look at the client height, of course, that's configurable when you click the legend here. You can configure it and you can visualize this at the client height, and the client height also does the same thing, right? So it actually stays on the slope. I don't know how well this is visible here, but I'll do my best to try to show that. So the client height goes like, 0, starts raising, and it's or like, how is it? It's in relation to the slope height. It's in relation to the raised floor height. And you see the signals hovering.
Yes, that seems sensible to me.
Okay, time for bed. Time to bed for you.
We'll end it on that note. Very good. Thanks, Jussi. Thanks, everybody.